Today we're going to be talking about how to evaluate a polynomial, and I'm going to show you a new way that you can evaluate to kind of build on what you already know about evaluating functions. And we're going to talk about the fundamental theorem of algebra that will kind of help you better understand what goes on in the middle of a graph. So last class we were talking about end behavior, and if you remember, end behavior is about what happens as x approaches positive infinity, as in when we go to the right side of the graph, and as x approaches negative infinity when we go to the right side of the graph. And then we finish that sentence with f of x goes either to positive infinity if it's going up, or to negative infinity if it's going down. Okay, so let's look at a concrete example that you guys already know about graphing, and we'll talk about evaluating it too. So this function, f of x equals x squared minus 2x minus 8. So we know that this is a quadratic, which means we know that it has this general U shape to it. It's a parabola. But where is the vertex, and what are the solutions, or the x-intercepts? So you guys have already learned about how to solve quadratics, and I can actually see that this is factorable. So take a minute, pause the video, factor this, and figure out what the solutions would be based on the factors. So hopefully you got x minus 4 times x plus 2, and those factors, if you pretend that f of x equals 0, you get x equals 4, and you get x equals negative 2. Remember, the relationship between factors and x-intercepts is that they have opposite signs. We'll use this idea more later. So you can go ahead and plot those x-intercepts. And now let's figure out what's going on in the middle. So what I would like to do, instead of finding the vertex, is actually evaluate this quadratic polynomial. So when I say evaluate, I mean finding the function value at different x values. So for example, we can find the function value at x equals 0 by plugging in a 0 for every x in this function. So that would be 0 squared, going in for that first x, minus 2 times 0, minus 8. So notice, 0 squared is just 0, minus 2 times 0, that's just 0, minus 8, we really just get the constant. And hey, this is old news to us. Remember that when a polynomial, when a quadratic is in standard form, we can get the y-intercept, which is when x equals 0, just from the constant. So we can go ahead and plot that on our graph too. And on your graph, there's not enough y tick marks in the y direction, so you can just count by 2's on the y-axis. And I went ahead and labeled my x-axis too, just so that it was clear to my viewer. Okay, so now how about when x equals negative 1? So that means plugging in negative 1 for every x in the function. Okay, so let's go ahead and pause the video and see if we can do that and get the same answer as each other. Okay, so I've set this up, plugging in negative 1 for every x. We know that negative 1 squared is 1. Be careful if you type that into your calculator that you type it with parentheses when you're checking yourself. But remember, you can do this without a calculator. Have some faith in yourself. So 1 plus 2 is 3 minus 8 gives us negative 5. So now we've got another value, so we can count down. Remember, my y-axis I counted by 2's, so we can put a little point right here at negative 1, negative 5. Okay, and we should also know, because we know that quadratics are symmetrical, if we have an x-intercept at negative 2 and an x-intercept at 4, we also know that our axis of symmetry should be at x equals 1. Remember, that's a vertical line, so we call it x equals. And we can kind of sketch this on either side, since we know that these are symmetric. This is my rough sketch without a grid. So now we've drawn this quadratic polynomial. And keep in mind, you learned something new last class about the end behavior of quadratics and other even and positive leading coefficient polynomials. So anything that has a positive leading coefficient and an even exponent as the degree is going to have this end behavior, whereas if we can finish the sentence that we started before, as x approaches positive infinity, that's the right side, f of x or y is going up to positive infinity, And as x approaches negative infinity, that's the left side of the graph, f of x is approaching positive infinity. So there's that end behavior that we already learned last class, plus what we already know a little bit about evaluating. So this that we were just doing is called direct substitution. That's just what we're used to doing, where we plug in to a function and simplify it. So just as a little reminder, when I say evaluate, what does it mean to evaluate? That means that you're just finding the y value for different x values on your function. So let's do another example where we're evaluating. So if I have this function, f of x equals negative 3x cubed plus x squared minus 12x minus 5, and I want to evaluate it when x equals negative 2, I'm going to plug in negative 2 for all the x's. And just to take a moment to look at this function, let's think about what kind of a polynomial this is. So we see that we've got a negative leading coefficient and we've got a 3 as our highest exponent. So this is a degree 3 polynomial, which we learned is a cubic function, and it's got that negative 3. So normally a cubic function has a shape, that positive, that increasing the whole time S shape. But because of that negative leading coefficient, we know that it's going to look something like this. It's going to be flipped over. So again, we're kind of using that concept when we get into sketching these more later. You can use this concept of end behavior to have an idea of at least what's going on the ends, and then we use this evaluating to figure out what's going on in the middle. Okay, so let's go ahead and plug in negative 2. So it's going to be negative 3 times negative 2 cubed plus negative 2 squared minus 12 times negative 2 minus 5. This is a little bit more work than what we had with our quadratic before. There's a few more terms to deal with. So keep in mind your order of operations. You always want to do the exponent before you multiply. So first thing we have to do is do negative 2 to the third, which is negative 2 times negative 2 times negative 2. Don't freak out. You can do this without your calculator. So negative 2 times itself is positive 4. If we multiply by negative 2 again, we get negative 8. So far we've got negative 2 cubed is negative 8. When we multiply that by negative 3, we get positive 24. Okay, so that wasn't so bad. Look, we did that without the calculator. Yay! Okay, so negative 2 squared. We can do that. That's negative 2 times itself. That's positive 4. Okay? Our next term, negative 12, we're taking into account this sign here, times negative 2. That gives us positive, because a negative times a negative is positive, 24. And then minus 5. All right, so now we're just tallying up what we have, and now we kind of have to flex our brain a little bit. So 24 plus 4 is 28, plus 24 is 52, minus 5 is 47. Okay, so that was a little bit more work than what we did before with the quadratic. Okay, so this is one way to do this. And remember, this is called direct substitution. So here comes a new method that we're going to use to evaluate polynomials. And I think that after you practice this a little bit, you'll probably like it better than direct substitution because it makes you work a little bit less hard. Okay, so let's give this a try. So we're doing the same problem as we did above. I still have the same function, negative 3x cubed plus x squared minus 12x minus 5. This is my cubic polynomial, and I'm trying to evaluate it when x equals negative 2. Okay, so what that means is I'm trying to find f of negative 2, as in plugging in negative 2. So the way we set this up is and eventually you'll be writing this yourself, but I have it set up for you in your notes first. So you put the x value that you're evaluating on the outside, and then you line up all your coefficients from this function. So by coefficients, I mean those numbers in front of all the x's. And as long as your polynomial is in standard form, you can just go in order. So my coefficient for my cubed term is negative 3. My coefficient for my squared term is 1. My coefficient for my plain old x term is negative 12 for my linear term. Okay, and then my constant at the end is negative 5. Okay, and I like to put a little line here. Again, I have this set up for you, but eventually you'll be setting it up yourself, and you'll see why we put that little line there. Okay, so here's the routine that we do every time, and I have it written down for you. So step 1, bring down. By bring down, I mean bring down this first term, -3. You're just going to write it down here on the bottom line, and then you're going to multiply this -3 by this -2. Okay? So -3 times -2 is +6. Okay, and now that you've got that, and remember I said it was positive, so technically you can write this if you want to, but you don't need to. You're going to be adding these two terms, 1 and 6, together, and you're going to write down your answer that you get, your sum of those, down below, so 7. Okay, and now we're going to do the same thing that we just did. Take this number, multiply it by -2. So 7 times -2 is -14, okay? Because that was negative, technically what I'm doing is adding a negative or subtracting. -12 plus a -14, or -14, is -26. And last thing I do, I'm multiplying this by this again. So, and I put that here. -26 times -2 is 52. Because it was positive, I'm adding, so I get 47. Okay? And remember, up here, I got that same answer doing direct substitution. Okay, so you might be saying, ooh, I did not like that. That's because this is brand new to you. So I think over time it's going to get easier, and you guys will probably come to prefer this way. But I would like you guys to know how to do both ways. So basically what we saw with direct substitution up above and with synthetic substitution, the way we just did it, we get the same answer, f of -2. Plugging in a -2 gives me a y value of 47. That means if I wrote this as an ordered pair, my ordered pair on my graph is -2, 47.